IFS is powering big enterprise, big ideas, and big change. With technology that enables companies to innovate and grow. With unparalleled industry depth that provides a way to create value by joining the dots. And how companies engage with their customers, empowering their people and use their assets so that they can deliver when it really matters at the moment of service. Touching our lives and improving the way we do business across the world.
From the moment we wake up.
To how we travel.
To the business we do.
And how we care for our world.
IFS is leading the way and empowering thousands of the world's most progressive brands. Let us help you be your best
at the moment of service.
To the perfect memories without hindering yours. The only proof of our presence will be the images and the moments that go beyond expressions for you to cherish for a lifetime. Now you see me, now you don't.
Good evening, fellow coding enthusiasts. Welcome back. It's an absolute delight to see you all here at day 2 of the Logit Labs, a 2-day online workshop series organized by the IEEE student branch of IIT in collaboration with the IEEE Computer Society of IIT, IEEE Women in Engineering Affinity Group of IIT, and IEEE Robotics and Automation Society of IIT. Today, we will delve into the fascinating world of object-oriented programming and engage in a lively discussion on to the past IEEE extreme questions. This session is invaluable for coders who aspire to master object-oriented programming and gain insights from past IEEE questions, equipping them to excel in the programming challenges that lie ahead. I'm Ranag Anthony, and I'll be your moderator for this evening. Without further ado, let me introduce our esteemed speaker for today's session, Mr. Sairu Bopitier, a software engineer intern at IFS, who will share his knowledge and expertise in the world of object-oriented programming and guide us through past IEEE extreme questions. Before we begin, you can find the Slido link in the Zoom chat. Feel free to drop your questions there. Stay tuned until the end of the session where we will address all your doubts. Also, a kind reminder that IEEE Extreme registrations will be closing by 18th midnight. So, if you haven't registered yet, do so immediately. Don't miss the opportunity to participate in one of the largest global hackathons to be ever organized. Mr. Bopitia, the stage is all yours.
Um, okay. Thank you, Ranuga, for that lovely introduction. I'd say. Hope everyone is having a very good evening today. Yeah. So as Ranuga mentioned, I'm Sarah Bopitia, and I'm a software engineering intern at IFS. And I'm currently pursuing my software engineering degree at IEEE. And yes, that's something small about me. So today, what your committee actually informed me was to conduct a session on OOP principles and take you guys through some of the basic past questions in IEEE Extreme and sort of a guide into competitive programming. So yeah, I'll share my screen. Mm, oops. Wait. Right. Let me know when you guys can see the screen. Can you see the screen, guys?
Yes, can see.
Yes, we can see.
Yeah.
All right. So yeah. Okay. Yeah, so this is today's agenda. So this is a basic check-in, and first I'll be going through OOP, which is I'll actually come to that next, and competitive programming, and then I'll do a small demo for you guys. Just do a live demo, code with you, so you can code with me as well, and that will sort of give you a hands-on session on how you can actually tackle competitive programming question. And then we can move to the Q&A session, and then we'll be closing the session now. So it's a pretty simple thing. So yeah, we'll start off with the basic question. OOP, I think everyone knows what OOP is. Can I see the chat? All right, okay. So yeah, I think Ranuga also mentioned what OOP is, but so yeah, so OOP means object-oriented programming, right? So this session I prepared in such a way that it's mainly focused on the first year students. So it will be somewhat basic, but it will be very important for the much senior undergraduates as well, for you to polish your current skills in OOP. So if there are any questions, you can, I think there's a Slido link. Yeah, so you can drop it there. So yeah, object-oriented programming. So I want this session to be interactive as possible. So can someone tell me why we need OOP or object-oriented programming? You can send it in the chat or unmute yourself. It's totally fine. Anyone? I'm sure you heard of object-oriented programming. So why do we need object-oriented programming? Okay. Okay, to simplify code or increase code. Right, nice. Okay. Thank you, Kamalika. So yeah, exactly what she said. So to get organized, modular, and maintainable approach into programming. So previously, before object-oriented programming came into place, earlier there was something called procedural programming, which was not a better thing than OOP, I would say. So OOP is the much more modified version, which came later. than procedural programming. So this is much more organized. It's modular and it's more maintainable. So it's not, I mean, it's important that we can write code that runs, but it's more important that the code is readable, it's organized, and it can maintain for quite some time. So those things are very important aspects when it comes to developing programs. So yeah. So I'll be quickly touching upon classes and objects, since if I think correctly, there might be someone who don't know what classes and objects are. So I'll be quickly explaining what classes and objects are. So yeah, if we take this example, right? I'm sure if anyone has a dog, if I take a class, right, I'll come back to what classes and objects are, but let's try to learn from this example first. So if I take a class called dog, right, and in this class, I have three things. I have an identity, I have attributes, and I have behaviors. So if I think of an identity, the dog should have a name, right? The class should have a name. And the dog should have certain attributes or values in it. So it can be the breed, it can be the age, and the color of the dog. And behaviors means a dog should, eat, sleep, bark, and run, stuff like that. So all these things combined, we call them members, right? So these come inside what we call a class. So that's all great. This is a great diagram. I'm sure what you get the basic idea of this, but how can we write a code that actually maps what's inside this diagram, right? So this is a code. I'm not sure if you guys can see it. If it's too small, can you guys see the code? If it's too small, maybe. Is it readable?
Yeah, it's a bit small, but it's readable. Yeah.
Right.
So, yeah,
Okay.
Yeah.
How about now? Can see.
It's better now. Yeah, can see now.
Right. Okay. So this is the basic implementation of the class. So if I'm not mistaken, most first years use Python for their language, right? Python. Okay, but I'll be using Java for these few examples. So I'll be doing the demo, first demo with you guys with Python, since you're most familiar with Python. But I'll come back to why I'm using Java in this session in the very end when I'm doing the competitive programming section. Okay, so for this, if you don't know the basic syntax of Java, this might sound like gibberish to you, and you may not may understand what this code means, but it's totally fine. Right? I'll be explaining the code, and you can do the same thing with programming language like Python as well. So yeah, if I take this Java code here, and here I have public class dog, which means I have declared the class here called dog. And inside this dog class, as I showed you in the previous diagram, right, there are few attributes. So those are name, breed, age, and color. So those we set variables here called instance variables. And then we actually create something called a constructor. So inside this constructor, oops, sorry. Yeah, so I'm sure you guys know what data types are. And here we have set the name to string, breed to string, and string means like a text. Okay, so age means a integer value and stuff like that. And then we have created a constructor to declare the class and public dog, and we have passed the four values here: name, breed, age, and color. And then we actually create four separate methods to get each of these values. So we have get name, get breed, get age, and get color. So we have created four methods for this. And then we have sort of, I'll come back to what overriding and overloading functions are in the next part. This is sort of like the way I want my output to be. So hi, my name is the get name, and my breed, age, and color are, and you can see the breed, age, and color. So this is how I want my output to be. So this dot get name, this part right here, this dot get name means whatever value I use, write down, right? This dot get name. The name round here is Woofy. So Woofy will be passed here, right? So the breed is Labrador, and Labrador will be passed here, and 5 gets passed here, and the color gets passed here. So what I basically do is, to the function which I created above, I'm going to override it with values that I get. So here, this is a class, and inside this class, I create an object called Woofy. Okay, so what I have done here is dog space Woofy. Woofy means the name of the object. All right, the name of the object, and I have passed these values into this, and then I have outputted these values, taken the output of these values here, Woofy dot to string. That's what I have done. I have called this method right here. So I'll go to the next slide. Maybe you can get much better idea from that. Oh no, sorry. Yeah. So as I mentioned, classes are like a blueprint of the object, right? Classes are used to create objects, and classes can only be declared once. And this is a group of similar objects, right? So if we think of objects, an object is an instance of a class, and we can create as many objects as we need, right? Previously, we created one called Woofy. You can create another one with one of your pets' names, say, I don't know, Brownie or whatever. So that's another object. And like that, just like that, you can create number of different objects, all coming under that specific class. And if that's also a real example, the dog thing, if we take another object, if we take another example, let's say car, all right? A car is also a real world entity, right? Car is a real world entity, and that's an object, okay? So there is this relationship between classes and objects. What you need to remember to properly differentiate classes and objects is that classes are like a blueprint of an object, and classes are used to create objects, right? So object is an instance of that class. So those are the two main things that you need to get an idea of to properly differentiate these two concepts, classes and objects. I hope everyone got an idea of that. If you did, you can you send me a thumbs up or something? Let me check. Okay, okay, cool. Right. The reason I touched on classes and objects first before coming into the OOP principles is because you need to have a basic foundation, solid foundation on what you need to come into OOP principles. So when we think of OOP principles or object-oriented programming principles, right, there are 4 main principles or concepts, and I'm sure some of you might have already heard it. Is there anyone who knows, who can tell me what are the four principles in OOP? I would very much encourage if you guys could unmute and tell me.
There's abstraction.
Right. Okay, abstraction. Okay, we have abstraction, encapsulation, inheritance, polymorphism, abstraction. Okay, inheritance, encapsulation, abstraction. Okay, cool. So yeah, all your answers are correct. So it's abstraction, encapsulation, inheritance, and polymorphism. So not in a specific order, right? There's no such thing as this should be the exact order. There's nothing like that, okay? So it can be in any order. It's just 4 principles that we use to properly apply object-oriented program. So I'll be covering each and every one of these principles. So abstraction, right? Which is the first one I can take. So abstraction is sort of simplifying a complex process or an object, as I mentioned before, by focusing on what's important, right? Let's say, you want to drive a car. You want to drive a car. So do you need to know everything that happens inside the car? Do you need to know, okay, how the engine works, how the wheels turn? Do you need to know all of that to just drive the car? No, right? You just need to start the car and go. I mean, there are some more steps, but that's basically the gist, right? Just need to start the car and, pedal the accelerator and just go. You don't need to know everything, every mechanism behind all those functions. So think of you driving the car. You are the user, you are the end user who's on the receiving end. Okay, that's what we call the end user. And what's exposed to you as an end user is the steering wheel, the pedals, and the stuff you can see when you're in this driver's seat, right? The side mirrors, the rear view mirror, and all those things. That's what you can see. You don't see what's inside the hood. You don't see anything like that. So that's the same principle that we use when it comes to abstraction, right? We focus on what's important. So this is important because when you're coding, this lets you avoid repeating code, right? This avoids code duplication. That's the term we use. Code duplication is avoided when we use abstraction in code. So I'll take this small example here. So if I create a class called shape, right? And there's something different here, right? We call this a public abstract class. So when it comes to abstraction, we use this term called abstract here. This is another mechanism which comes under abstraction. So inside this abstract class called shape, I have its own variable called color, and then a constructor method which will initialize the shape. So what we have right here, and then I have a method called get color, and I'm returning the color. And then I have an abstract method called get area. So basically what this does is this code actually is like a general code which I can write to get the area of any shape. It can be anything, right? You can use the get area method to get the area of a shape. All right. So how we can use this is because if I go back, you can see inside this get area, there is no logic written, right? There's nothing written here. It's just get area, right? Have I said I need, okay, because, okay, let's do it like this. If you want to take the area of a circle, right? That's different. That's a different formula for when you want to take the area of a square, right? So we can't just use one general thing. Okay, you need to use this exact same thing called get area, and that works for all the shapes. No, we can't do that. So in those cases, that's when abstraction comes into place. We extend the shape class to another class we create called circle. Let's say I want to find the area of a circle. So from shape, I'm extending circle. From that, I have its own a unique attribute called radius. So when it comes to finding the area of a circle, radius is the one that plays a huge role. So pi r squared, right, for a circle. So here we use radius, and here we actually pass the same thing, color, and yes, here, all right, this is the one that I want to mention before. I override the abstract method, which is here. Here we just made the method called getArea, and now inside the circle class, I'm overriding that previously created method called getArea in a way that I want to calculate the area of the circle, right? So it's math.py. Math.py is what we use to get, this is sort of like constant, right? So those are math constants that we can get. You don't need to write 22 divided by 7 or 3.1427, stuff like that. You don't need to write that. You can use math.py and multiply it by r radius into radius. So once you use this, you can get, once you feed the values for the radius, you can actually get the area of a circle. So this is an example of how abstraction works. So is anyone clear on this before I move on to the next one? Oh yeah, are there any questions? I'm sort of rushing through this a little bit. The reason is because there's so much to learn when it comes to the OOP principles. I mean, you can't do it in a small session like this. You need to be focused and learn how the proper implementation works. But I have actually summarized this in a way that you get the most basic idea of what you need to get started. So if there are no questions, I can move to the next principle. Yes.
By the way, Sairu,
Yeah.
can I call you that? Yeah.
Yeah, sure.
So since we are having the Q&A session towards the end, like we can go
Oh,
to
okay.
slides first,
Okay,
right?
I can continue the session. Then we can
Yeah.
ask the questions at the. All right. Okay, Ranuk. Sure. Okay. So take notes on those questions, guys. Right. Yeah. Okay. I'll move on to the next principle. So this is encapsulation, as you mentioned. So when you learn about encapsulation, we talked about methods and attributes and all those things before, right? So when it comes to encapsulation, what you need to remember is in encapsulation, we allow or we limit access to certain things, right? So this is better explainable in example once I get into that, but just remember for now, right? We use encapsulation to keep our code organized, right? And prevent some sort of unwanted stuff happening around our code, dependency issues and all those things, right? So that's what we do in encapsulation. And this is a better example. I'll come to the access modifiers part later. All right. So this is a better example what I will use. So this is a class, this is a capsule, right? And think of this capsule as a class. This capsule has two parts. I'm sure you have seen the capsule. And this top part, I'll call it methods. And the part on the bottom, we'll call it variables. So we have methods and variables. All together, we combine it, we call it a class. So when we combine methods and variables together, we call it encapsulation. So this is the binding of both methods and variables into a single entity, right? So I'll go back to this part again, just to give you an idea about what encapsulation is. So I told you we use this to limit access, right? So when it comes to limiting access, in programming, we have a concept called access modifiers. And in access modifiers, there are 3 main parts or 3 main types, I would say. So we have public, private and protected. When it comes to public access modifiers are used when members are accessible from any part of the program. Members means, classes, variables, all those things, objects. So what you define as public will be accessible in any part of the program, right? So when it comes to private access modifiers, these are only accessible within the class they are defined in. So if I define an object or a variable within a class, right? Those can be only accessed within that class. No other class can access those variables or objects, right? So when it comes to protected, this actually ties in with inheritance, which I'll get to in a bit. So when it comes to protected access modifiers, those members, the objects and the variables, are accessible by subclasses of the parent class, subclasses of the class which they are defined in, right? So if you don't know what subclasses or child classes or parent classes are, I'll be taking you through that when I cover inheritance part for you. So what I just basically wanted to let you guys know is there are things called access modifiers, and which we use when we write code to cover encapsulation. So there are three main parts: public, private, and protected. So yeah, so this is an example. So I here have the same thing that I showed you guys previously, the shape class, and here, just as before, I have a private variable, right? I have a private variable called string color, and I am retrieving this private. I'm using this color variable here to get for this get color method, right? So yeah, so what I have done here is this variable called color. This cannot be accessed by any other class. Why is the reason? The reason is because this has been defined as private, right? If I define this as public, then there won't be an issue, right? The other classes can also access this. But since this can only be accessed, since this is defined as private, only the public class called ieeeiit is the only class that can access this. So that's the basic concept when it comes to access modifiers, which is used in encapsulation. So yeah, I'll go to inheritance next. So when we think of inheritance, the most commonly used analogy is parent and child, right? So when it comes to inheritance, we can allow it to create new classes. The new classes we call child classes. And these child classes are actually based on the existing parent classes. So if we have a parent class and we create some child classes of that parent class, those child classes will inherit the attributes and the methods of that parent class. And in addition to that, the child class can have some values on its own, right? So just as to similar how we are, right? We get sort of genetic information from our parents. But in addition to that, we have, some certain qualities of ourselves as well. So it's the basic analogy that we use to explain inheritance. So if we take a look at this one, here we have a class called animal. And here we have two attributes, color and size. And there are three methods called eat, sleep, and walk. And for this animal class, there are three more subclasses called dog, cat, and cow. All of these are animals. But each of these classes has their own unique method or their own unique function. Dog has bark, cat has meow, cow has moo, right? So why is this important? What if I put the bark method here to the animal method here? What will happen then? Then all the animals will be able to bark. The dog can bark, the cat can also bark, the cow can also bark, which is, not correct, right? So the correct thing is they should have unique methods on their own. So that's where inheritance comes into play. So the animal class, or the class on the top, we call it the parent class. And the classes on the bottom, or the subclasses, we call these child classes. Another term for these two we use are called, for parent classes, we call them superclasses. And for child classes, we use the term subclasses. So parent child is also used, but also superclasses and subclasses are also used. So it's totally fine, but you need to have an idea is about, okay, what inheritance is, right? If you think of inheritance, your mind should go to, okay, parent child. That's what your mind should go to. And that all the stuff gets inherited down to the child. And also the child can have some unique attributes and values of their own. Okay, so hope everyone got the idea of inheritance. Yeah, so sorry. So this is the implementation of the diagram I showed you here. So here we have the animal class, or the parent class. Here I have created that class here. So here we have two variables, color and size, and the three methods. The animal is eating, the animal is sleeping, the animal is walking, right? And then for this parent class, I have created three subclasses, or three child classes, which you saw before: dog, cat, and cow. So it's important, you can see we have used the term extends here. You saw it before as well. So when we actually create a child class, we use the term extends, the keyword called extends, to specify, okay, this is getting inherited from something. This is getting inherited from a class called animal. So that's how we specify inheritance, right? And here, if we look at the dog class, you can see that it has its own unique method called bark, right? And I have put a print statement called the dog is barking. And for cat, we have meow, and moo. For the cow, we have moo. So that's the basic explanation of inheritance. And the reason why I'm showing you each and every implementation after explaining you all these principles is because it's not enough that you know the theory behind the OOP concepts or the principles. You need to know how these things are implemented. This not only helps you to apply that knowledge, but also to better understand what's behind these principles, right? If you didn't see this code, you might not truly get what I was talking about. But some of you, I mean, most of you might have gotten it after I have showed you the code. Okay, this is what happens in this concept or something like that. So it's important to work with code most of the time. I would say most of the time, all the time, because that's where the entire implementation happens, right? So application is truly important. So polymorphism, is the last concept. And when it comes to polymorphism, um, poly means many and morph means forms. So polymorphism means many forms, right? So what does that mean, right? How does this apply to OOP, right? So let's say I have, I can use the same example, the previous one before. So if each animal sounded the same way, right? If all the animals in the world only barked, then we don't need polymorphism, right? Then we don't need polymorphism, but that's not the case. Each animal sounds differently, right? So this is what we use. This is what we use inheritance. This is what we use polymorphism for. So by using polymorphism, we allow different objects to have to respond to their own unique way. We have we create a method call, right? We create it in a way that we override the previously initialized method call. So I'll explain it with a code, which is much more always easier, I would say. Yeah. So I have the same animal class, and you can actually see this structure right here, right? So this is the parent class, and these two are the child classes, dog and cat, right? So I have a method called animal sound for the animal class. And here I have said, okay, the animal makes a sound. And I have created two subclasses here, or two child classes for the animal class. And in the dog class, right, I have overridden the animal sound method. I have overridden and I said, okay, not the animal that makes the sound, it's the dog barks, right? Here we have overridden the animal sound, right? And when it comes to the cat, we override the same animal sound method and say the cat meows. So I hope you got the idea of how different polymorphism is when it comes to inheritance, right? When it comes to inheritance, it had its own unique method. The dog had bark and cat had meow. So when it comes to polymorphism, it's the same method. We are just overriding it, right? So yeah. So I created this because I wanted to show you guys the output here. So I created the class called polymorphism, and I called all these methods, right? It's the same method, but here's the catch. Before each method, before the same method animal sound, I have added this part for my animal, my dog, my cat, right? So after I run this file, after I run this main file called poly, I get the following output. The animal makes a sound, which is the first one, and the dog barks and the cat meows. So these print statements I get from here. These are the print statements I get called from. So all these are called into this class called poly. And so once I run it, I get this following output. All right. So this is how polymorphism works. And yes, those are the basic things that I want to cover in object-oriented programming. So, I mean, there's so much more when it comes to OOP, and and I'm sure that you will be covering it in your module, in a future module as well. But to give you guys a basic idea on what OOP is and how to actually use this when it comes to programming, I believe this is more than enough, because we covered classes and objects and also the key aspects of OOP, which is abstraction, inheritance, polymorphism, and wait, I forgot. Wait, what? Encapsulation. I'm sorry. Encapsulation. So these four things. So it's important to know this stuff when coding, because that only makes your code more in a more quality way, and it improves readability, modularity, and the maintainability of your code. So these are some things that are more important when moving forward with competitive programming. So I think we'll hold questions to the end, right, Anuka? So we can continue with competitive programming.
Yeah. Yes.
Yeah.
Because we
Okay.
are having a Q&A session, you can continue.
Right.
Yeah.
Okay. Okay. Uh, Moving to competitive programming now. So this is what's really important, and I want to focus on a bit more. Um, so this is my performance on last year's competition. So it's a funny story, this one, because last year, this was actually last minute that I signed up for the extreme competition in last year. So I had to participate alone, and that was really stressful because I had no idea, and that was the first time actually I participated in this. And at that time, I realized, okay, this competition is actually meant for teams, right? Because some of the questions are not trying to pull you guys down, but some of these questions are a bit more complex, and it's not easy to tackle them with one brain, right? Obviously, I mean, anyway, not for me, but not sure you guys can. So I was placed the first in my university and 55th in Sri Lanka. So I mean, it's not a huge amount, but I consider it a win. So what I'm going to do is I'm going to share my experience with you guys and how you can use this session as a sort of foundation to start on the competitive programming and IEEE Extreme, right? So competitive programming is a mind sport or a e-sport, and this is for programmers. So the funny part about this is there is more math involved. So there's a lot of logical thinking, there's a lot of analytical thinking involved. So, and it all comes with a limited time frame, right? So there are many aspects to consider when it comes to competitive programming, and that's what makes it difficult. But it's also what makes it interesting, right? So it's an amazing thing. This is actually been done very and taken very seriously worldwide. And yeah, so why is competitive programming important, right? I'm sure you might be wondering that, why is it important? So it sharpens your algorithmic thinking. I mean, the previous session, if I not mistaken, was did cover the data structures and algorithms part. And I hope you guys got an idea of what the basic data structures and algorithms are, because those are really needed, right? More like compulsory when participating into competitive programming into a competition such as extreme, right? So you need data structures and algorithms because those are used a lot when it comes to tasks. So, and yeah, this sharpens your algorithmic thinking, right? It's not only knowing the algorithm enough won't help you solve the problem, right? You need to know how to apply that algorithm into your solution, right? Into the problem, how to solve the problem. So that part is done by practice and practice, right? So that's why that's how important competitive programming is, right? And yeah, all these concepts I mentioned, data structures, algorithms, OOP, uh, object oriented concepts, all these things, um, those are the sort of theoretical stuff, but competitive programming is a area where you can practically apply these concepts, and that is very valuable, I would say. So it's a practical application of all these concepts. So that's really important. And yeah, it's valuable for job interviews as well. So if you get placed in a, let's say, ranked in this competition, you can showcase that on your CV or someplace. So that will be a huge push for you in a technical interview. And not because it looks good on your CV, because you learn something from the competition, and that will help you, that will make your technical interview much easier. So yeah, That's how important competitive programming is. So yeah, this is sort of a guide on how to get started on competitive programming if you are new to this area. So what I would suggest is pick a language, right? Just one or two languages. Two is more than enough, right? But yeah, I suggest two, right? As first is, I believe you guys already know Python, right? But I would suggest is, yeah, Python is good, but it's also important if you guys, when it comes to competitive programming, I mean, right? Most of the competitive programmers use C++ or Java. The reason is of the execution time, right? Execution time. And when it comes to the execution time of Python, it's much higher. And when it comes to the execution time of a low-level language such as C++ or Java, it's comparatively low. But I wouldn't say that's the most um, uh, general case, right? Because this mainly depends on the solution, right? And it depends on the task, and mainly depends on the solution that you provide to that task. So there can be instances where Python is the best solution. There can be instances where Java or C++ is the most ideal solution. So it's better to know two languages, right? So you can shift between these two languages, because when it comes to competitive programming, there is no such restriction saying, okay, this is the only language you should use. There's no such thing like that. And there is no advantage over other languages, so you can use any language which you want. But you need to be proficient. You need to know that language very well, right? The syntax and its libraries and stuff like that. So yeah, be proficient in a programming language. That's the main thing. And yes, I mentioned this before, data structures and algorithms. So this is important, and you'll see why when we do the demo. So this is very vital. Okay. And yeah, dynamic programming. This is actually a bit advanced, but and I won't suggest us in this right now as beginners, because when it comes to dynamic programming, we have, I mean, you might get some questions for IEEE Extreme. I'm not really sure, but you might get some dynamic programming questions, which are based on the Fibonacci sequence, um, exponentials, what else? The shortest path, stuff like that. So there's some math involved, some complex math involved when it comes to dynamic programming. And for those stuff, you need to have the basic math knowledge for that. So knowing just the computer science aspect of it will be a bit difficult when approaching a dynamic programming question. So I'll tell you how you can overcome that barrier when it comes to the end, how you can overcome that mathematical knowledge barrier if you don't come from a maths background. So that's totally fine, right? That's entirely okay. So I'll get to that part in the end. Yeah, time complexity and space complexity. And this I mentioned before. So I said there's this execution time to tasks, right? So when it comes to IEEE Extreme, there are two things you will see in the demo. We have the execution time and we have memory limit, right? Execution time is what we call the time complexity, and the memory limit is what we call the space complexity, right? So you can write the code. If, let's say you are given a task, right? And you can write the proper code, and that's okay. Code is also fine. Compiles, you get the correct output, all good, right? So when you click submit, right? When you hit submit on the IEEE Extreme platform, several test cases start running, right? There are several test cases running in that platform. And in those test cases, they have the input they have they send an input to our program and check if they get the desired output. They check that. They also check the amount of time it was taken to execute that program and also the memory, right? So if the time is exceeded, even if your test gets passed, let's say you get the desired output, but even it takes a long time to execute, still you might lose some marks, right? So there is a time limit there, and also the memory limit is also there. So that's something that's very important when it comes to competitive programming. And I'll get touch that once we come to a demo, how important that is. And that's why sometimes knowing a low level language might give you a little bit of edge over knowing a high level language like Python. But for easy questions, right, easy tasks, Python is more than enough, right? You can use Python for those questions, so that you have nothing to worry about for that. And with everything, practice, practice, and more practice. So you need a lot of practice, right? I'll show you once we go to the demo. We actually last year we had this competition for IEEE Extreme, and there I did the submission. I got the 100% for that, so I got the full points for that. And my execution time was around I don't know, 256 MB. I can't remember. So it was a pretty large amount, right? And then after the competition, we can look at the answers and stuff like that. And once I looked at one answer, and it was like the most ranked guy, right? And after looking at his answer, I saw that his execution time was 1 millisecond, right? And I was shocked because the level of competence that you need to have to write a program that not only works, but works in the best possible way, right? In the most perfect way with the lowest execution time. So for that, you need so much of practice. And I'm sure those guys have practiced a lot also. So it's like any other thing, you need practice, practice, and practice, right? So yeah, now it's the demo time. Before I move to the demo, do we take questions or shall we wrap the demo first?
We'll go with the
Yes.
demo time, right? Yeah.
All right. Okay. So can you see this one, this screen?
Yeah. Can see. Yeah.
Okay. So I'll send this link to the chat as well. Everyone in the meeting. Right. So this is sort of an archive that the IEEE Extreme guys have kept, which contains sort of sample questions and some past IEEE Extreme questions for you guys to try out. So these are really helpful. And depending on there is a difficulty there, right? So the difficulty here is easy, medium, hard, and no, it doesn't stop there. There's another level called hardest, right? So there are 4 levels of difficulty, and usually the easy, there's no such thing as you can't try the hard ones, because if you check a question like this, okay, I got 90 points for it, but still, okay, and this is easy. And this wagon, this shows that how many people have actually attempted this and got this correct, right? So around 70% here. So let's see a hard one. Right, okay. So this is a hard one, right? This is a hard difficulty question, but still 78% of the people were able to pass the so pass the task, right? So not that hard, right? So this is sort of a question bank where you guys can use to these are sort of like exercises for you guys to do before you go to IEEE Extreme. So this is very valuable. And the great thing about this is it actually has these categories, right? So if you click this show tags button here, right? Let's say you need to improve on wait, hash maps. Okay. And this gives us the questions that they have for hash maps. So you have dictionary pagination and the Fibonacci, right? So when it comes to hash map, it's a different part, different data structure, right? So what I would suggest is before you suddenly go and start doing one of these questions, let's say you start with the easy one. Even before that, what I would suggest you is, if you're not familiar with uh, the data structure or the algorithm you find here, look at that first, get that theory into your head, uh, uh, see what, okay, this is what we do in hash maps, and get that into your head first, and then go to apply this in a task, right? Because if you go straight into a task, you don't know how to apply because you don't know what to apply, right? So that's something that I recommend for you guys to do. And yeah, I actually got a question. I searched one for you guys, which I thought was pretty good. Yeah, so you guys can try this out, right? And the rank is also shown here. So I'm currently, I mean, I haven't tried all these, but I'm currently 5,600. So you guys can also try this, okay? Can try all of these stuff. Most of them are a bit complex, right? And we have that dynamic programming stuff that I mentioned before, right? You have these mostly related to math, right? But you can tackle these questions as well, because you can start off with an easy one. Always start off with an easy one, right? Always start with an easy one and then move up, right? I mean, I would say finish all the easy ones first and then go to the next level. That's what I recommend. But if you feel like you can do it, you're more than welcome. Because these questions are a bit different, right? It's not your basic programming question that you get. This is a little bit different. It has a very specific format. So to get that idea into your head, you must do the questions, all right? So I actually found a question, which is this. Okay, sorting partition. Okay, this is the question that I wanted to demo with you guys today. I'll send this link as well, right? See if you get it. You got it, right, in the chat?
Yes, I. Yeah.
All right, okay. So I'll first explain the problem statement, as we call it, and then I'll go into how we can tackle the solution, all right? So yeah, as I mentioned before, you can see there's a execution time limit and a memory limit. So this is the time complexity and this is the space complexity. So the time limit here is 2,500 milliseconds, which doesn't seem which might seem like a lot, but it's not. It's milliseconds, okay? And the memory limit is 128 MB, right? So if we take a look at the question, so this is an easy one, right? So you are given an array of n integers. So you have n number of integers, and you should partition this array into subarrays, sort each subarray independently. Performing these sorting operations lead to entire array being sorted. Right, okay. So what I would recommend for you guys is come to this link and I recommend if you guys could code with me, that would be great, because you guys will also be coding with me. So that's how you could be tackling this question together, right? Yeah, so if you get this idea right here, so we have an array of n number of integers. We don't know how many, right? And the thing that we need to do is we need to partition this array, right? Partition means, in the sense, we need to divide this into several segments, right? So we are dividing the array into several sub arrays, and then we sort these arrays independently. We divide them and we independently we sort them out. So yeah, if you look at this question, right, in anywhere in this problem statement, did you see anywhere stated like, okay, this is the algorithm that you need to use, this is the data structure that you need to use, right? No, right? It's not mentioned in the problem statement, because that's the part where you need to figure out, okay, this is the thing that I need to use, this is the algorithm I need to use. So that's something that you need to figure out. So to figure out that part, you need to know the algorithms, you need to know your data structures, and you need practice, right? You need the practical application of this part. So I actually did this question so just to check if it gets executed. So I know what algorithm to use, but I'll just share it with you guys, right? So for this problem statement, we use an algorithm called the greedy algorithm. Anyone here heard of the greedy algorithm? Can raise a hand, or I don't know what. You can put to the chat, right? I mean, if anyone could tell me what a greedy algorithm is, that would be great. We have time. Has anyone heard of the greedy algorithm thing? Okay, all right. Okay, so I'll explain what the greedy algorithm is. May I know, just out of curiosity, like in the previous session, when it came to data structures and algorithms, what kind of algorithms did the speaker cover? If anyone remembers, maybe some of them, maybe. So I can maybe use some of them here. Okay, no worries. Okay, so I'll explain what greedy algorithm is. All right. So greedy algorithm is greedy. Okay, and why we call it greedy is that algorithm uses the best option available at that given time, right? So in this case, we need to divide the array into several sub-arrays, right? And we need to sort them at that step. We divide them and we sort them at that step, right? So you can look into, I won't go into much detail of the algorithms part, because we'll be talking all day if we start talking about the greedy algorithm. So I just mentioned for you guys what the greedy algorithm is, because you guys need to know what we're getting into, right? So in the greedy algorithm, we take the best option at that time. It's not the best option overall. It's not the most perfect option, but it's the best for that time, right? So, and the reason why we call it greedy is because it does not ever, it never reverses and goes back and says, it never changes its decisions, right? We never say it goes back and rechange the a decision and say, okay, no, this is not the best option, this is the best option. It never does that. It sticks with it. So that's why we call it the greedy algorithm. So yeah, that's something about the greedy algorithm. So coming back to the problem statement again, we have the standard input here. The standard input in the under the standard input, it says the first line contains a single integer n and the length of the array. Okay. Second line contains the n values of the array. Right. That's the standard input. That's how you should input the values. And the output should contain a single number, one integer, representing the maximum number of subarrays of a valid partition. Okay. So we input in 2 lines. If you can see here, they have given some sample inputs, outputs, and some explanation. They do this not only in these sample questions, they do this in the IEEE extreme task as well, right? So if you didn't understand it in this part, you can always get some sort of idea once you look at the input, output, and explanation, right? So in addition to that, we have some constraints here. So n should be a value between 1 and 10 to the power 5, and the values of the array are between 0 and 10 to the power 9. Okay, these are some constraints. The lower limit and the upper limit has been set for these things. So you can see once we set an input 7, 3, 1, 2, 4, 100, 7, 9, the output is a single integer, and the explanation is given here. So you should partition the array into the following subarrays, right? Like this. So this part is one array, this is one array, and this is another array. So here we have, this is the first array, this is the second array, this is the third array. So we have 3 arrays. That's the output that we get. All right. So here they have given us 2 input output parts, right? So the great thing about this platform is you don't need to code in the IDE, upload it to the platform, right? You can code it within the platform itself. I mean, you have that option. You can open file and do that, but you can just run it here, right? No need to open the IDE and do that stuff, right? So since in this platform, it supports almost like most of the popular programming languages, right? So once you open it, probably must have been C++, right? Can use Java, C, Python. So there is sort of, I wouldn't say template, but yeah, I mean, it's sort of a template that they have given for each language, right? So you can use this and edit this code in a way that you can run and compile this program, right? So since most of you guys are familiar with Python, I'll be using Python for this question. And the next question, I'll go and use Java, because Java is very important when it comes to knowing a low-level language is sort of important when it comes to programming, competitive programming. So I sort of recommend you guys to learn a programming language, right? A low-level programming language, because we use that a lot, right? Yeah, so I hope everyone got an idea of the problem statement. If you didn't get an idea, I mean, you can always ask me in the chat or something. I have it open, so I can answer, right? Yeah. Right. Sorry. I'll open the workspace to the full window so that you guys can see the code. Do you guys see the code, or is it too small?
Yeah, we can see the code side. No issue there.
No issue there, right? Okay. Better if I can. Yeah, I have both open. Okay. So I'll explain from the top what this is. I mean, there might be some guys here who aren't familiar with Python, so I'll explain from the top. So what they have given us a command, a simple parser for Python, and use the get number method and get word method to read, right? They have given that sort of rule there, right? So we should use that, right? So this part right here, def parser, and this part right here. So this is what we call a generator function in Python, right? And this is used for passing the input. This is used for passing the input. And we have a while loop here, so not much to think about here, right? We don't need to change anything here, right? And here we have the input parser. Here we have initialized the generator, the input parser generation. The parser is there, and we have initialized the generator there. And we have the two methods here, get word and get number here, right? So get word is to get the next word from the input, right? And get number is to get a number. And inside this get number function, here we have try, and this tries to convert the input that we get into an integer data type, right? This is what it does here. So if it is possible, it returns as an integer type. If it's not possible, it returns the input, it converts the input into a float and returns it as a float data type. So this is why we have a try here. So the data type conversion is what's done here, right? And then you have, the usual import for libraries, NumPy and SciPy. I don't think we'll ever use these two, but let's just keep it like this, right? So, and then finally we print something called res. Okay. Okay. All right. So now we can get started on the coding, right? Exception handling.
No,
I didn't get it
actually,
done.
that the try except block, it's basically it's called exception handling, right?
Yeah.
That's
The try catch block. Yeah.
exactly.
Yeah, that's true. So we can get started on the code. So I hope everyone got an idea of what we should do here, right? So first, we have this print res part. So I'll, since this is not the part that we need, I'll remove this part. What do you think? Shall I add code comments as I code for you guys to better understand the code, or just keep coding?
I think if you can add comments, that would be
Okay.
better.
Okay. So, okay. Okay. So, I'll first initialize a variable. For result, right? So we print the res here. So result as res. So then I'll first initialize it as 0. And next I will read the length. Wait a minute. Length of the array. Okay. Okay. All right. I'll use one called length, and I'll call get number here. Get number method. And now I have read the length from the input, and now I need to have some arrays, right? I need to initialize arrays and store the inputted numbers into those arrays. So here, when you think of arrays, this is where the problem statement logical thinking part comes, right? So when approaching a question, you need to break down the problem statement. You need to break this down into several parts where you can understand, right? What I usually do is I usually write this down in a way I can understand, because if you look at this problem statement, it's a bit intimidating and a bit overwhelming. So you just write it down in a way that you can understand, right? And then you approach the solution, right? Even if you get the idea, okay, this is how I should write the solution, what I will suggest you to do is break down the solution also, right? Break down the solution as well, saying, okay, first do this, then I can do this, then this, sort of like steps. And then you can write the code for that. You already have the logic in your head, you just need to implement it, right? So that's what's important, getting the logic here, right? So I will initialize arrays to store now, I'll call it numbers. And not only numbers, we need the cumulative sum as well, right? Because we are getting this part, we are sorting this part as well, right? And we are doing the partitioning stuff in these arrays, right? It's not just getting an array, we are dividing into partitions as well. So we need the cumulative sum for this. So I'll call the number array as nums, and yeah, length, yeah, right. Okay, then sums length. Okay. Okay. Now we have initialized some arrays to store the numbers and the cumulative sums, right? So next we need to create another variable to keep track of the cumulative sums. Okay, so for that, I'll call it init. Okay, can't write the whole thing. Initialize variable to keep track of cumulative sum. Right. We need a name for this one. We'll call it. Okay. See, this is the difficult part. Coming up with variable names and array names, it's very difficult, and keeping track of that part. So we created initialized a variable to keep track of the cumulative sum. And so now we have created the arrays, right? We created the required variables. So what we need now is to read the numbers, right? And calculate the cumulative sum and store them in the arrays, right? So we have already created the arrays, we need to now store them. That's the part for that we should do. So for this, read, let's say compute and store to array, right? Okay. For this, we need to write a condition. Let's write a loop. I'm sorry. For I in range length. Wait, okay, better. And then I'll call the first one nums I and get number, right? Get number. So this will actually read the number, right? Yeah, this will actually read a number, and then the cumulative sum array, which the cumulative sum should increment, right? Okay, my bad. Okay. for the usual normal array. So I can add a comment here saying add the number to the cumulative sum. I hope you guys are following this. If you guys are following, can you just send me a thumbs up to know that you guys are following this? I'm not sure if you have, I don't know, like seen this as gibberish or something. I mean, if you can't explain, can't understand anything, more than willing to explain what the problem statement or anything is. So, can I get a thumbs up or something? Okay, all right, okay, nice. Okay, okay, we got a few thumbs up. Right. So now we read a number and we added the number to the cumulative sum array, and now we need to store that in the sums array, right? So that's what we're going to do now. So sums I, and this part, this cumulative sum array name here, this will actually store the cumulative sum in the sums array. Right, so that is our for loop now. Now the reading, computing, and the storing part is done, right? So now the basically sort of like the hard part is done, right? So now what we need to do is we need to sort the arrays, right? Because they have clearly mentioned we need to sort each sub array independently, right? So this is what we're going to do now. We need to sort the nums array, right? This is the array we're going to sort, the independent one. So in Python, we have this sort thing, right? So we can directly call nums.sort, right? This will sort the array. So, I mean, that's the great thing about Python. It's very easy to code in Python, and the development time is much less. But I mean, you guys will see once I compile the code and run the execution, how much of a execution time it will take compared to other programming languages. I'll show you guys that as well. So we sorted the array, and now we need to create a variable to keep track of the sorted numbers, right? I'll call that, what was the previous one? Nums. Okay, I'll call this nums. Okay. All right. So we created a variable for that. Now, right. We need to do the sorting part. All right. Now we need to go through the sorted numbers and do a comparison of the cumulative sums, right? So for that, we need the for loop. And inside that for loop, we are going to add the current number to the cumulative sum. And then we do a comparison. We compare the sum of the sorted numbers, right? Yes, compare the sum of the sorted numbers with the cumulative sum of the original. So, wait, did I mess up? No, okay, I got it. Okay, so we first add the current number to the cumulative sum, right? That's the first thing that we're going to do inside the for loop. And in the next line, we are going to compare the sum of the sorted numbers with the cumulative sum of the original numbers, right? So if they match, if the comparison is okay, if they match, we are going to increment the result count, right? We are going to do all of that inside a for loop, right? So let me know if you guys didn't get anything. I'll keep coding, just let me put a message, all right? So iterate spellings, iterate through sorted nums and compare cumulative sum, right? So write a for loop here. So I in range length again. Okay, num sum, which is this variable here, which we use to keep track of the sorted numbers, right? And here we are going to add the current number to the cumulative sum, right? And nums I, yeah, all right, to the cumulative sum. Okay. So add current num to sums. Okay, that part is done. Now we need to do the comparison part. So here I'm going to check if cumulative sum of sorted nums with the cumulative sum of the original numbers. Okay. All right. Okay. That's, and if num sum, which is this variable, and is equal to sums I, then if they match, if num sum is equal to sums I, then the result will be incremented by 1, right? You can say increment result count. Yeah, I think that's it. Yeah, that's it. So at the end, you can use the same print statement. You can print final result. Oh, okay. So the final result. No, fine. So yeah, this is the code. I think this is the code. Let's just run this and see. Let's just compile this first. Okay, compilation done. Nice. Okay, so you can see the exit code is 1, so most probably it's going to be okay. And so here you can see the CPU time as well. So CPU time and the memory line. So I'll run the sample test cases. Oh, hold on. Right. So you can see, yeah. So both test cases have passed in the sample test case. But the thing that you should know is like the first test case took 287 milliseconds to execute, and the test number 0 took 288 milliseconds to execute. So that's the thing with Python. With Python, the execution time is pretty high. And these are sample test cases, right? And with IEEE Extreme also, they have sample test cases, example ones, which you can do with run examples, but that alone won't get you the full marks. You need to submit your solution, right? Once you submit your solution only, you will be awarded points. And once you click submit, you can see progress bar here. Ah, nice. Okay. So happy when it turns green. Okay, so you can see there were 11 hidden test cases, right? 11 plus these two sample test cases, right? Sort of like unit tests, but I mean, you can my bad. What happened? I think it gave me a limit or something. Oh, okay. Wait, I will change something in the code. Okay. Okay. Now I need to show you this guys as well. So if you make an error in the code and you click compile, right? This shows you where the error is, right? So this is an IDE, right? This is an online IDE edit. So you can use this and you can actually fix this. And I need to change something in the code for this. Let's remove these two parts. You don't need that, I guess. Yeah. Right. Okay. I just needed to show you guys this. So you can submit the same solution twice in 1 hour. It seems okay. You can do multiple submissions in IEEE Extreme, right? You can do multiple submissions and there won't be a penalty, right? So you can do multiple submissions, and with that, actually, so the important thing you need to know is you need to do it with the quickest time possible, right? So since I did this task before, I was able to pass all the test cases, right? Because I had the basic idea, but you usually don't don't get the idea in 10-15 minutes and start writing the code like this, right? So you need to have some time for that, and that's what's important. So the important thing here you need to know is, when starting off with a question, you just need to write the proper solution first. In your first submission, you don't need to think about passing all the test cases. You don't need to think about the execution time. You don't need to think about the memory limit. The only thing that you should have in your mind is to pass at least one test case, right? If you pass at least one test case, then you get some points. You get, I think, 30 points, I think. So so that's what's important. After you do that first submission, you can confirm, okay, my logic is correct. So now what you have to do is optimize your code. We call this code optimization. Write your code in a way that the execution time is comparatively low, memory limit is low, and in a way that you can pass all these test cases, right? So if you go take a look at these test cases, you can see the inputs here, right? Okay, so test number 3 has used this input. So for this input, the output should be 10. And with our program, I think we have gotten 10, which is why we have passed it, right? So you can take a look at these inputs. I mean, these are pretty huge inputs, right? So this is what these are the test cases that are there in the hidden test cases, right? So examples.
By the way, Cyrus,
Yeah.
so let's say if somebody is like having a question where they must be thinking now, what's the maximum time limit they should spend on one particular question? So what's the answer for that?
Right. Well, It depends, right? If I remember correctly, so the extreme competition is 24 hours, right? So if I remember correctly, they send out a question. Is it 1 hour, each 1 hour, or each 30
Yeah.
minutes? I'm not sure, right? So if you're participating as a team, let's say for 24 hours in the platform, it publishes a challenge every 1 hour, right? So the competition starts at 12 a.m. You get your first question at 12 a.m., the next question at 1 a.m., right? So there's 1 hour gap. Within that 1 hour gap, you should attempt the first question. That's how you usually do, right? So what you need to, the answer to your question is there's no
Yeah.
like specified time limit to say, okay, you can tackle all the questions in this particular time. If you can't, you should give up, right? Let's say you get an easy question like this. The time you should spend for this, I mean, probably you guys could get it in 1 hour, right? Most probably you guys can. And let's say you are faced with a complex challenge. The thing with complex challenges are, if you attempt a complex challenge, the points are high, right? Compared to a easy one, the points awarded are high. So it's okay to spend some more time working on that hard question because you will get some more points, right? But it's the same with any question. It's the same with any task. The only thing you should remember is you should follow the steps, right? Read the problem statement carefully, break it down, and then move to the solution, break that down. And then once you got the logic correctly, you know what algorithm to use, the data structure to use, then you can start working on the solution. So no specific time limit set for to attempt a question. Ranabir. I mean, it depends on the question, obviously.
All
Okay,
right.
got your answer.
Yeah. Yeah.
Okay. Thank you. So this is pretty much it, what I wanted to show you guys in this platform. So this is a great platform, right? So this is the code that I wrote in Python, right? And the great thing about this is, and this is not available in IEEE Extreme, right? These are only available in sample questions archive you find here. You can find these buttons here for the editorial, right? And this actually, yeah, so it says the greedy approach. So, and gives you the solution and the official implementation. If you take a look at that, right? Okay, so this has been written in C++. Okay, so this is what I wanted to show you guys, right? So our execution time took how much? How much did it take? Okay, so some of them took 125. Okay, that's good actually, right? His execution time was only 41 milliseconds, right? Since this is an easy question, not a hard difficulty question. Hi, can you guys hear me now?
Yes, I
Hello?
can hear you.
I think there was a network issue on my end. I'm sorry about that. I'll share the screen again. Once again, sorry about that, guys. I was using my hotspot, but some problem there. Anyway, so you can see the screen, right?
Yeah, we can see the string.
Right. So the execution time that's what I was talking about. I mean, this matters when it comes to complex questions. So since this is a small question, it's totally fine. And you can check out these answers and the discussions which these guys have done, right? Solutions with the lowest CPU time, so 5 milliseconds, right? So these are the solutions which people have done. And this is our one, okay? So take a look at this platform. That's what I want to say, right? Explore this platform, explore these questions, the different types of categories of questions, right? And that will really help you. And there's another thing that I want to show you guys. It's another platform called Code Forces. And in Code Forces, this is something that I actually found out pretty recently. And not, I mean, you can find IEEE extreme questions, past questions in Code Forces as well. But the good thing about Code Forces is there are contests here, right? Just like IEEE extreme, right? There are contests here. So you can participate in those things as well. And that will really help you. And I'll send this link as I'll send the home. So wait. Where is the chat? All right, okay. Okay, so you can take a look at this website as well. And I actually selected a question to do with you guys, but I don't think we have that much of time left. I think it's 8:20 now. So this is a question which I found was pretty good for you guys to tackle as beginners. So I would love to share the code for this as well. I actually made the code, but I mean, it's okay. You can find the submissions for this as well, right? So similar to the IEEE Extreme platforms question, this is the same structure, right? So you can see the execution time is there, memory limit is there, and the input, output, and the examples are here, right? So, but the only bad thing I would say about this platform is there is no online IDE for this. So you should code on your local IDE and upload it as a file to here, right? So yeah, accepted. So take a look at this as well. There are contests here. So these will be really helpful if you want to sort of, get prepared for IEEE Extreme, because the questions you get aren't that easy, I would say. They're a bit difficult, but not too difficult in a way that can be accomplished, but it just needs some practice for that, okay? So yeah, I think that's it for the demo. Did I miss something? Wait, did I miss something? No, right? I think I covered everything. Yeah, okay. So yeah, it's pretty much it for the demo. I was going to do 2 questions with you guys. This one in Java, this question in Java, but because of the time limit, I don't think we have time for this. But try this out yourself, right? And try the questions in the CS Academy. Start with the easiest ones and work your way up to the top, right? So yeah, coming back to the slide. Wait, yeah, I think your committee will also mention this part. There are some rules in IEEE Extreme, and I mentioned this before. So it starts at 00 UTC and ends at 23 hours and 59 minutes and 59 seconds. So any programming language is supported, and there is no advantage over other, but keep in mind about that execution time thing, right? So as we went through, each task will have time and memory limits, and you can submit any number of times yes you want. You can do so many submissions. You won't be penalized, right? But what they recommend is you try to solve the tasks as quickly as possible, right? Do any number of submissions as you want, but just do it in the quickest way possible, right? And they have a very dynamic ranking system in their platform. It's a bit complex. I'll show that one as well. So this is the problem score, right? That you will receive after you solve a question. So 30 is the mandatory mark they allocate for solving a question. I'm not sure if this is outdated. I got this from their website. Maybe the IEEE committee can also double check with these guys. So 30 is the mark that they allocated. So if you at least pass one test case, you will be awarded 30 marks. And depending, they won't actually specify this question is easy, this question is difficult, right? They let the people decide, sort of thing. So if, let's say, not many teams are able to solve that question, the question will be deemed as difficult, right, or hard. So depend on if the question is hard, the average points and the marks that you get here, this part right here, 70 multiplied by 1 minus average points. This part here are extra points, additional points, in addition to the 30 points. So this part here is depending on whether the challenge is easy or hard. So if it's hard, the number of points that you might receive will be high. That's why I mentioned try to tackle a difficult question, right? Because you might get some extra points there compared to an easy one. So it's important to try both easy and difficult questions both. So this is just what I wanted to mention. So this average point is a value that's between 0 and 1, right? So it can be a decimal point. It is a decimal point. So depending on that, this number goes up or high. And yes, to finish off, some tips before you go to the session. Participate as a team, please, because it gets really stressful. Don't try to compete as an individual. I mean, I won't recommend competing as an individual for 24 hours because it gets really hectic, and don't try this because it's also more fun. Last year, I think it was 2 or 3 hours before the deadline I registered. So I couldn't find my friends to team up with me. So since you have time now, I think it's 18th your registration deadline. I'm not sure. 18th,
Basically,
right?
18th midnight
18
until
midnight. Okay. Yeah. Okay. So you have 2 days, right? So form a team and participate. And as I mentioned before, try to solve as quickly as possible. The more quickly that you solve, the more points you may earn. And get some sleep, get some rest. It's better if you guys get together in some place, maybe in a university, and do the competition and polish your DSA skills, right? Data structures, algorithms, and maybe take a overall look or a high level look on dynamic programming a bit before you go. Might be important for the competition. And yes, a little bit of math. Actually, not a little bit of math. A lot of math is involved, but because you need math, right? When it comes to competitive programming. And I mentioned you need to, how can you bridge that gap, right? Overcome that barrier. So if you feel like, okay, I need to improve my math skills a bit, there is this book. I'll actually send these links to the chat, right? So there's this book called The Competitive Programmer's Handbook. This is very valuable. I read parts of this. It's a not pretty huge book. I have read parts of this book, and this is focused on competitive programming and covers the mathematical parts that you need to know to tackle competitive programming questions, right? So take a look at this, right? And the Code Forces website and the CS Academy website. And the Atcoda is a Japanese website. So the questions are a bit difficult, but they are really good. The solutions they have are much more detailed. and there's a good community there as well. So take a look at that as well. And I'm sure most of you guys have heard of the Google competitive programming competitions, right? So Code Jam, Hash Code, stuff like that. So take a look at the Code Jam and Hash Code archives here. I'll send this link probably. Oops. It, yes. Okay. The links should work, I guess. Yeah. And yeah, that is pretty much it for me. Once again, thank you, IEEE, IEEE student branch for inviting me for this session. I hope you guys learned something from this. So if you have any questions, I think we can go to the Q&A. Ranuga.
Yes, so thank you so much, Sairu. So you went in depth to like explain each and every concept in double OOP. And before that, you explained what the basic concepts of Java as well. So thank you so much. And you also like went into how to approach an IEEE extreme question also, like all the minute details also you stressed over them. So thank you so much. Thanks a lot. So
No worries. Thank you.
yeah, next we have our sponsors. So obviously without them, this event wouldn't have been possible. So we definitely have to mention them. So our role partner is Causen, who specializes in UX research and design, prototyping, building SaaS and mobile products, and cloud engineering. And next, we have our bronze partner, WSO2, enables fast and secure digital experiences through open source and SaaS technologies. And obviously, our workshop partner, IFS, where Saira is an intern as well. So they deliver award-winning solutions for businesses aiming to excel in customer service, especially during their moment of service. And next, we have our technical partner, ieeeiit, renowned as the best sellers of Apple products at affordable and reasonable prices. Next, we have our digital media partner, Now You See Me, provides a variety of digital media services, such as event photography and video production. And we have our knowledge partner, STEMlink, focusing on boosting proficiency in school subjects. And finally, we have our venue partner, EdSat Pro, who excels in quality assurance and test automation for trading and post-trade systems. We extend our heartfelt gratitude to each of these companies for collaborating with us and helping to bring our ideas to life. So now that that's over, let's jump into the Q&A session, guys. So I invite Sarah to take the stage and address any questions that our participants may have come up with.
Yeah, I actually came to this slide. Shall I look at the questions and answer? Or?
Yeah, I mean, if it's convenient for you. Yeah,
All right. Okay. Okay. So what does this mean in a constructor? I believe you mean this dot something, right? Inside a class. I think that's what you mean in the constructor. So this is a keyword that in object-oriented programming, this is a keyword. So this basically refers to the current instance of a class, right? The current instance of a class. If you guys remember correctly, when I was explaining, I have added some codes saying these are instance variables. So this is a current instance of a class. So this is commonly used in constructors because we need to differentiate between instance variables and parameters, right? parameters or local variables with the same name. So there can be names with there can be variables or uh, parameters or instance variables or what we call fields with the same name. So to distinguish that, we use this. So to clear that part out. So this makes it clear that you're working with, okay, an instance variable rather than local variable. So there are two types of that. So I hope you got the answer. Ah, it's anonymous. Ah, okay. Right. Okay. Can we get the presentation file? Yeah, maybe. Yeah, sure. I can send it to your organizing committee. Maybe they can share it with you guys. I can send the link. I can PDF it and send it to you guys. Maybe they can arrange it to you. Right. Okay. Can you explain about protective and default access modifiers? Okay. So protected means what I mentioned before. If you think of the inheritance concept, right? If I define something as protected, protected means it allows access to a member within the same class, right? Its subclasses and the classes, right? So if I, let's say, call, if I declare a class called, let's take the same thing, right? Parent, declare something called parent. And inside parent, I initialize a protected variable, protected one. And then I make a child class out of it, right? And then I can access that protected field from that from a subclass. I can then access that protected field which is in the parent class from a subclass. So that's only specific to that same class and the subclasses inside which is it's defined. And also default is there, right? So default access modifier, mostly it's called, I think it's called private, package private, I think. So yeah, if it's not only just three, I think as told it was three main access modifiers. So it's public, private, and protected. But in addition, we have the default access modifier as well. So default is also called the package private access modifier. So so what that does is, if I'm not mistaken, this default access modifier allows access to the member only from within the same package, right? So if you call it from another package, you don't have access, but the classes and other stuff inside the same package, then it won't be an issue for default access modifiers. Yeah. What does super? Super, right? Okay. So super is a keyword and a constructor call to invoke. I'm not sure if you heard the term invoke. So invoking a function, right? So we use super to invoke the constructor of the parent class from the constructor of a child class, right? If I repeat it again, we use super to invoke the constructor of the parent class from the constructor in the child class, right? So hope you got the idea. I mean, I can go into the code and explain as well, but I mean, you can show it. That's the basic idea of super. Is it more advantageous to use Python in the competition while considering execution? Considering execution time, I would say no, because if I write a code in Java, the execution time is low, right? I showed you guys earlier, the code written in C++ took very less amount of execution time, but what we wrote in Python took like double the amount, right? But you don't need to think of it too much, right? You just need to I mean, this depends on the task actually. So depending on the task, if the task is an easy difficulty one, if the task is easy, you can always approach it with Python, right? And I mean, you can approach any question with Python, but if you feel personally, if you feel like this is getting too long or too complex for Python, you can switch to the another programming language such as Java, right? So first try to, I won't say, the first thing is not to think about execution time or uh, the number of test cases passed. The first thing you need to do is find the proper solution. Once you find the proper solution, you can get one test case, at least one test case passed, right? Once you get that, then you can start optimizing your code, right? So yeah, you can use anything. That's totally fine. What's the next one? Can you define what classes and objects are without using each other, right? What do you mean without using each other? All right, okay. You mean like separate definitions? Okay, so a class is a blueprint or a template, right, to create objects, right? So a class will define a set of attributes and behaviors or methods, right? So these defined set of attributes or methods that objects created from that class will have. So if we create a class with, let's say, several attributes and methods, those will be there once we create an object, right? So the structure for an object comes from a class. I hope you got the idea. The structure which you need to create an object will come from a class. I hope that was clear. I mean, okay. Can you explain me about this usage of static keyword? Right. Okay. So static key is used in sure if it's used in Python though, but it's used in Java, right? So static key is used to declare elements, variables or methods or whatever, which are associated with the class itself, rather than instances of that class, right? So static is used to declare stuff inside the class rather than, let's say, objects, right? So when it comes to static keyword, there are static variables and there are static methods, right? Then there's another thing, I think, static nested classes or something. So there's another thing like that. So those are within the class, right? So those, once you use static, static keyword, it is not tied to another specific instance, right? And you can sort of like use multiple instances use directly through the class itself. I mean, this will sort of improve your code in a way so that it will be tightly coupled. Your code will be tightly coupled together. So in that way, it's using static key is good. A pretty long explanation. I didn't know if you get it. Right. Okay. How did you practice before facing extreme? Okay. I actually looked at DSA, data structures algorithms, and I did some questions in the CS Academy. I did a lot these questions in CS Academy, and I went through DSA, and there was another thing. All right, lead code. I did a few questions in lead code. I didn't do a lot in lead code. Some were relevant, some were not so much, because of that I shifted to CS Academy. So you can check out Lead Code as well. So Lead Code is there. I think there's another one called Neat Code. I'm not sure. So there are all very competitive programming type sort of questions, but you need to prepare for extreme. I would suggest polishing your data structures algorithms and doing some CS Academy questions like the one we just did right now. So yeah. Okay, so the next question is, how do we polish our DSA knowledge? Well, the first thing is you need to learn the data structures and algorithms, right? So there are number of data structures, there are so many algorithms, right? And the trick is you don't know which algorithm to use in the solution. So right. You don't know which one to use. So that before you know which algorithm to use, you should know the algorithms, right? You should know the data structures. For that, you should learn them. Go to YouTube, or you have Google right now, or now yes, you have ChatGPT now. So you have these options. Learn from them the concepts first, the what's behind these data structures and algorithms. But as I mentioned before, learning them is not enough. You need to apply that knowledge practically by doing questions, right? You need to keep practicing. That's why I mentioned, like, you should do a lot of questions in the CS Academy. If you do a lot of questions in the CS Academy, first go by levels, right? First do the easy tasks level, and then go to the medium one, then go to the hard one, then if you're if you're ambitious, you can go to the hardest one. So yeah, I mean, it all boils down to practice. So yeah, you need a lot of practice. And yes, the answer to the other question, don't use ChatGPT when facing extreme. I mean, I'm not sure if they check for plagiarism this type. I don't really know that, but I mean, this is not just about winning, right? You need to learn something. And the questions that you see in extreme are some of the best, right? You can learn so much by exploring those questions. So yeah, try to turn them alone.
That's about it, I guess. So thank you very much, Cyril, for dedicating your time and to address our queries. And you explained a lot. Like for each question, you explained like each step. So thank you very much. Obviously, you must have like answered their questions very thoroughly. So thank you for that. So on behalf of the organizing committee, we extend our profound gratitude for your illuminating contributions. So we sincerely hope that you accept our virtual tote of appreciation as a symbol of the invaluable knowledge you have generously imparted to all our participants today.
Yeah,
Now,
thank you. Yes, go ahead. It's okay.
as we conclude today's successful session, I want to express our sincere gratitude to each and every one of you who joined us today. Your active participation is greatly appreciated. We hope that today's session has been a valuable experience and that you have gained a profound understanding of object-oriented programming and the world of IEEE Extreme. Once more, thank you for being a part of this event. We wish you a fantastic night ahead.